Welcome to your personalized deep dive. Today, we're going to be diving into the blueprint of AI systems.
Okay.
Like OpenAI's O1, the brainy machine that seems to be everywhere these days.
Yeah.
It's like reverse engineering a genius.
Exactly. We're going to be unpacking a research paper
Okay.
that lays out a potential roadmap for recreating a system like O1. By understanding how it's built, we can get a glimpse into the future of AI.
You share this paper with us, so we know you're fascinated by these powerful AI systems. Let's get started. The paper focuses on 4 key components: policy initialization,
Yeah.
reward design,
Right.
search, and learning.
It's like figuring out the secret ingredients in baking instructions for a super intelligent cake.
Okay, I love that analogy. So let's start with the foundation.
Okay.
Policy initialization. What's that all about?
Policy initialization is where the AI gets its basic training.
Yeah.
It's like teaching a child the ABCs of language and how to think logically.
Okay.
Think of it this way. First, we feed the AI massive amounts of text data.
Right.
Basically, the entire internet's worth of information.
Wow. That's a lot of information. What does the AI actually do with all that data?
It absorbs it like a sponge. This process called pre-training allows the AI to develop a fundamental understanding of language grammar and even general knowledge about the world.
So it's like giving the AI crash course.
Yeah.
Everything humans know. But how does it go from understanding language to actually solving problems?
That's where instruction fine-tuning comes in.
Okay.
We refine that raw knowledge, making the AI more focused on responding to human instructions, requests.
Okay, so it's like teaching a dog to sit before you can teach it to fetch the newspaper.
Exactly.
You need those foundational skills first.
And just like training a dog takes patience and the right techniques,
Yeah.
getting AI to reason like a human is a complex process.
And speaking of reasoning, this paper dives into 6 specific human-like reasoning behaviors that O1 demonstrates.
Yeah.
Problem analysis, task decomposition, task completion, alternative proposal, self-evaluation, and even self-correction.
Right.
That's a lot to unpack.
It is. But think about how you approach a complex problem. You probably start by analyzing it, breaking it down into smaller steps, and then working through those steps.
Right.
You might even propose alternative solutions or evaluate and revise your approach along the way.
Yeah.
That's essentially what these reasoning behaviors allow the AI to do.
Okay, so the AI isn't just magically spitting out answers.
Right.
It's actually thinking things through step by step, just like a human would.
Exactly.
That's pretty mind-blowing.
It is. And the paper gives some really interesting real-world examples of these behaviors in action.
Okay.
For instance, when tackling a coding task, O1 might analyze the problem by saying, so the user is requesting a bash script. Let's first understand the input and output formats.
It's like the AI is thinking out loud, just like a human programmer would. And the paper also mentions O1 working through a cipher problem, right?
Yes. It goes through a series of steps, saying things like, check the number of letters, let's test this mapping, let's check this with the second pair. It's fascinating to see how O1 approaches these problems in such a human-like way.
It is. It's almost eerie how closely it mimics our own thought processes.
Yeah.
But if AI can already reason like this, what are the limitations?
Well, one challenge is ensuring these reasoning behaviors are effective across different tasks and situations. While these behaviors are present in the AI after instruction fine-tuning, their effectiveness depends on how we guide them. Think of it like having all the tools but needing the instructions on how to use them.
So it's not enough to just give the AI a bunch of information and expect it to figure everything out on its own.
Right.
We need to guide its reasoning process.
Exactly.
How do we do that?
That's where reward design comes in. It's all about giving the AI feedback to nudge it towards the desired behavior, much like we use positive reinforcement to train a dog. But there are some important nuances here.
Okay, I'm intrigued. How is rewarding an AI different from rewarding, say, a dog with a treat?
It's about rewarding the process of reasoning, not just the final outcome.
Hold on. Why is rewarding the process so important? Wouldn't just rewarding the correct answer be enough?
Not necessarily. Let's say you're training an AI to write code. If you only reward the final program that works, it might find shortcuts or even cheat to get the right answer.
So it's like rewarding a student for showing their work.
Exactly.
Not just for getting the right answer on a test. We want to encourage a deeper understanding of the material.
The paper gives an example where researchers trained an AI to solve multi-step reasoning tasks when they only rewarded the final answer.
Right.
It actually hindered the AI's performance because it became fixated on the outcome without truly understanding the underlying reasoning.
That makes a lot of sense. So how do researchers actually design these reward systems? It seems like it would be incredibly difficult to account for every nuance and possibility.
You're right. It's one of the big challenges in AI.
Yeah.
There are several methods, each with its pros and cons. One approach is using feedback from a realistic environment. If you're training an AI to write code, you could reward it based on whether the code actually compiles and runs correctly.
Okay, so it's like giving the AI a real-world test to see if its code actually works. What if it's not practical to test the AI in a realistic environment? What are some other methods?
For tasks that are too complex or expensive to test in the real world, we can create simulated environments. Think of it like a virtual training ground. For example, you could train a self-driving car AI in a simulated city before letting it loose on real roads.
That's a great way to put it. And for tasks like creative writing, where there isn't a clear right or wrong answer, we often rely on human feedback. It's like having human judges for an AI talent show.
We could have humans rate the AI's output or provide critiques to guide its learning. And there's another approach that's gaining traction.
What's that?
Using AI judges.
Whoa, hold on. AI judging other AIs. How does that work?
It involves using a more powerful pre-trained AI to evaluate the output of the AI being trained. It's a way to leverage the capabilities of existing AI systems to provide more sophisticated feedback.
Okay, that makes sense. It's like having a panel of AI experts critiquing the work of a student AI.
Exactly.
And the paper dives into some really intriguing specific technique.
It does. One method is reward shaping, which involves transforming sparse outcome rewards, like a simple pass or fail, into more dense and informative process rewards. This helps guide the AI more effectively.
So it's like breaking down a big reward into smaller, more frequent treats to keep the AI motivated.
Another method is using potential-based reward shaping, which is inspired by the concept of potential energy in physics. It essentially rewards the AI for moving closer to a desired state, even if it hasn't achieved the final goal yet. Think of it like encouraging the AI to keep climbing uphill, even if it hasn't reached the summit yet.
I love that analogy. Okay, so based on all this, what kind of reward model do you think O1 might be using? It's clearly a very capable system.
Right.
So it must have a pretty sophisticated reward system in place.
That's a great question. Given O1's ability to handle multitask reasoning, it likely uses a combination of these methods. For complex tasks like math and coding, a process reward model would be more effective than simply rewarding the final outcome. And techniques like reward shaping could help derive those process rewards from simpler outcome rewards.
That makes sense. But what about tasks where there isn't a clear right or wrong answer? Like creative writing or art? How would you reward an AI for being creative?
In those cases, O1 likely relies on learning from preference data. Maybe even data from human experts. It might involve training the AI to recognize patterns in how humans rank or judge creative works.
So it's like having the AI develop a sense of aesthetics or style by learning from human tastemakers.
Exactly. And considering O1's ability to be fine-tuned using just a few examples, it likely possesses a robust reward model trained on a vast and diverse data set spanning multiple domains. But even with these sophisticated techniques, designing effective reward systems is one of the biggest challenges in AI research.
What are some of the challenges researchers are facing? Does the AI ever try to game the system?
Absolutely. One major hurdle is reward hacking, where the AI finds ways to maximize its reward without actually achieving the intended goal. Think of it like the AI finding loopholes to get its treats without doing the actual work.
So it's like the AI figuring out how to cheat on the test without actually learning the material. Are there any other challenges?
Another challenge is dealing with sparse rewards. Imagine training an AI to write a novel. You can't really give it a reward after every word or sentence. The reward only comes at the very end, when the entire novel is finished.
So it's like the AI having to work for a long time without any feedback.
Exactly.
Which could make it difficult to learn effectively.
So researchers are constantly working to refine these reward systems and find ways to make the feedback more informative and timely. One promising approach is using reward ensembles,
Okay.
where multiple reward models, each trained on a specific task or domain,
Okay.
are combined to provide a more comprehensive and robust signal.
So it's like having a diverse panel of judges to ensure a more balanced and accurate evaluation. What other approaches are researchers exploring?
Another idea is to use natural language feedback instead of relying on simple numerical scores or labels.
Okay.
Imagine training the reward model on human critiques or explanations written in natural language.
Yeah.
It's like teaching the AI to understand nuanced feedback.
Yeah.
Just like a human student would.
That's fascinating.
Yeah.
But it also seems incredibly difficult to implement. Wouldn't natural language feedback be incredibly complex for the AI to interpret and process?
You're right. It's a cutting-edge area of research, and there are definitely challenges. One issue is ensuring the quality and consistency of the human feedback.
Okay.
People can be subjective and inconsistent in their evaluations, which can make it difficult to train a reliable reward model.
Makes sense.
Yeah.
It's like having a panel of judges with wildly different opinions and preferences.
Yeah.
Are there any other challenges?
Another hurdle is designing fine-grained reward signals for language models.
Okay.
Language is incredibly nuanced. It's not always clear what constitutes a step or an action in a complex language task.
Yeah.
Should the AI be rewarded for each word, each sentence,
Right.
or for the entire output?
That's a great point. It's like trying to figure out how to reward an author for writing a novel. Do you reward them for each word of each chapter or for the finished book?
Exactly. And the challenge becomes even greater for complex tasks like code generation or mathematical reasoning. It's not always easy to break those tasks down into smaller, rewardable steps.
Right. You can't just reward an AI for writing a line of code if the entire program doesn't work.
Exactly.
So it seems like researchers have their work cut out for them.
They do, but they're making significant progress. And the reward design techniques we've discussed are playing a key role in shaping how these systems learn and evolve.
Okay, so we've covered policy, initialization, and reward design. What's next on our roadmap to understanding O1?
Now we enter the fascinating realm of search.
Okay.
Even humans use trial and error to solve problems, and AI is no different.
Right.
Search is all about allowing the AI to explore different possibilities and strategies to find the best solution.
So it's like giving the AI the freedom to brainstorm, experiment. I like where this is going.
Exactly. And just like humans, AI needs guidance during this exploration process.
Okay.
That's where the concept of search guidance comes in.
All right, I'm all ears. Tell me more about this search guidance thing.
There are two main types of search guidance.
Oh, yeah?
Internal and external.
Okay.
Internal guidance relies on the AI's own internal mechanisms to evaluate and choose between different possibilities. Think of it like the AI using its own judgment and knowledge to guide its search.
So it's like the AI having an internal compass.
Right.
That points it in the right direction.
Yeah.
What about external guidance?
External guidance relies on feedback or signals from the environment or from external models.
Okay.
This could include rewards penalties or even feedback from human experts.
Yeah.
It's like the AI having a coach or mentor to provide direction.
I see. Internal guidance is like intuition.
Right.
Well, external guidance is like having a teacher or coach.
Exact.
Do those approaches ever overlap?
Absolutely. Combining internal and external guidance can be a powerful way to leverage the strengths of both approaches. We could use internal guidance to quickly narrow down the search space, and then use external guidance to fine-tune the search and select the best solution.
So it's like using your own intuition to come up with a few ideas.
Right.
And then seeking feedback from others to refine those ideas.
Precisely. And speaking of refining ideas, let's move on to search strategies.
Okay, I'm ready. What are search strategies and why are they important?
Search strategies are the methods the AI uses to explore the search space.
Okay.
They dictate how the AI moves from one possibility to another and how it decides which paths to explore. Choosing the right search strategy is crucial for efficiency and effectiveness.
So it's like having a roadmap or a strategy guide for navigating a complex maze.
Exactly. And there are two main types of search strategies: tree search and sequential revisions.
Okay, let's climb this AI knowledge tree. What's tree search all about?
Tree search involves building a tree-like structure where each node represents a possible state or action, and each branch represents a sequence of choices. The AI explores this tree, evaluating different branches and pruning away unpromising paths.
So it's like the AI exploring all the possible forks in the road and choosing the path that seems most likely to lead to the destination.
Precisely. One of the most well-known tree search algorithms is Monte Carlo Tree Search.
Okay.
Or MCTS for short. It involves simulating many random playouts from a given state to estimate the value of different actions. It's not about actual gambling, but it uses a similar concept of randomness and probability.
Okay, so it's like the AI playing out thousands of hypothetical scenarios in its head to figure out the best move.
Exactly. What's fascinating about MCTS is that it can be adapted to different action granularities.
Wait, action granularities, what does that mean?
It refers to the level of detail at which actions are defined. For example, in a language task, the actions could be defined at the word level, the sentence level, or even the paragraph level.
Ah, I see. So you could have MCTS working at the level of individual words, sentences, or even entire paragraphs.
Precisely. And the choice of action granularity depends on the specific task and the AI model's capabilities.
Okay, that makes sense. Does the paper give any examples of how MCTS has been adapted for different AI tasks?
It does. For example, researchers have used MCTS with word-level actions to improve the fluency and coherence of text generation.
Okay.
They've also used it to ground language generation in factual knowledge, preventing the AI from hallucinating or making things up.
So it's like using MCTS to keep the AI's imagination in check and make sure it stays grounded in reality?
Exactly. Others have used MCTS with step-level actions to tackle multi-step reasoning tasks like solving math problems or planning a sequence of actions.
So MCTS can be used for a wide range of tasks, from generating creative text to solving complex problems. Okay, so we've got MCTS. What about sequential revisions? How does that search strategy work?
Sequential revisions involves starting with an initial solution and iteratively refining and improving it based on feedback or evaluation. It's like starting with a rough draft and then revising and editing it until it's polished. So it's less about exploring a vast tree of possibilities and more about focusing on one path and iteratively improving it. Kind of like how a sculptor might start with a block of clay and gradually shape it into a masterpiece.
Exactly. This approach can be more efficient than tree search because it avoids exploring unnecessary branches. However, it might not be as effective if the initial solution is far from optimal.
So it's a trade-off between efficiency and exploration. Are there any specific examples of how these search strategies are used in practice?
Let's start with tree search. One example is best of n sampling, or BON for short. This involves the AI generating n different solutions and then choosing the best one based on some evaluation criteria.
So it's like an AI brainstorming session where the best idea wins. The paper mentioned that Bond's accuracy improves as the number of samples increases.
Yes. Even small AI models can achieve near-perfect accuracy with enough samples demonstrating the power of search. But it can become computationally expensive as the number of samples grows. Right, there are limits to how much brainstorming the AI can do. What are some ways to make Bond more efficient?
One approach is speculative rejection.
Okay.
Where the AI quickly evaluates partial solutions and discards the bad ones early on. It's like weeding out the bad ideas before they have a chance to fully develop. Another approach is to fine-tune the AI model to mimic the distribution of Bond, essentially training it to generate higher quality solutions from the start.
So it's about either being more selective about which solutions to explore, or training the AI to be a better brainstormer in the first place.
Exactly.
What about beam search? I remember reading about that in the paper as well.
Beam search is another widely used tree search algorithm. It keeps track of the top K most promising partial solutions and expands those solutions step by step. It's like the AI focusing its attention on the most likely paths and ignoring the dead ends.
So it's like having a flashlight that only illuminates the most promising paths in a dark forest.
Exactly. Traditionally, beam search has relied on the probability of each word appearing next in a sequence. But recent advances have incorporated additional signals, like rewards or value functions, to make it more effective.
So it's like upgrading the flashlight to be more intelligent and selective. The paper also mentioned reward-guided beam search, right?
Yes. In reward-guided beam search, the AI uses a reward model to evaluate different partial solutions and guide the search. It's like the AI following the scent of rewards to find the best solution.
I love that analogy. It reminds me of how dogs use their sense of smell to track down their favorite treats.
Yeah.
So we've covered Bond beam search, and earlier we touched on MCTS. Are there any particularly interesting examples of how those search strategies are used?
Absolutely. For MCTS, researchers have used it with token-level actions to make text generation more fluent and coherent. They've also used it to ground language in factual knowledge, preventing the AI from hallucinating or making things up. For example, in a task where the AI was asked to write about a historical event. Using MCTS, helped ensure it stuck to the facts, and didn't invent fictional details.
So it's like having a fact checker built into the AI's writing process.
Exactly. And for beam search,
Okay.
researchers have used it to improve code generation.
Okay.
They've incorporated techniques like value models and backtracking to balance exploration and exploitation, ensuring that the AI explores a diverse set of possibilities while still focusing on the most promising paths.
Okay, that makes sense. It's all about striking a balance between trying new things and sticking with what works. But are there any drawbacks to using beam search?
One potential drawback is that it can sometimes get stuck in a local optimum,
Okay.
meaning it finds a solution that's good but not the absolute best.
Right.
It's like getting lost in a maze and finding a dead end even though there's a better path somewhere else.
So it's like the AI needs to be careful not to get too fixated on one particular solution?
Exactly.
Okay, so we've covered tree search, Monte Carlo tree search, and beam search. What about sequential revisions? Any interesting examples of how that strategy is used?
One example is self-refine,
Okay.
where the AI generates an initial answer and then iteratively refines it based on its own self-feedback. It's like the AI having an internal dialogue, critiquing its work, and making improvements along the way.
Wow, so it's like the AI is its own toughest critic.
Exactly. Other approaches involve the AI reflecting on or improving its next action based on feedback from the environment or from an external model. For instance, researchers have used sequential revisions to enhance code generation, enabling the AI to debug and refine its code based on errors or test results.
So it's like the AI is learning from its mistakes and iteratively improving its skills just like a human programmer would. But are there any situations where sequential revisions might not be the best approach?
There's some debate about whether AI models can self-correct properly without external feedback, so it might not be suitable for tasks where external validation is crucial.
Okay, so it's an area of active research. And there's still much to learn about how best to use sequential revisions. Can tree search and sequential revisions be used together?
Yes, they can. Researchers have experimented with combining these strategies.
Okay.
They might use tree search to generate an initial set of solutions and then use sequential revisions to refine those solutions.
So it's like using tree search for brainstorming and then sequential revisions for polishing and refining those initial ideas.
Yeah.
I love how these different strategies can complement each other.
It is fascinating. And before we delve into learning, there's one more concept related to search worth discussing: the inverse scaling law.
Ooh, inverse scaling law.
It sounds intriguing.
It means that sometimes increasing the scale of search can actually make performance worse.
Wait, really? I thought more search was always better.
It's counterintuitive, I know. This inverse scaling is thought to be related to something called distribution shift. Imagine the AI is taking a test.
Okay.
If the types of questions on the test are different from the types of questions it studied for, it might not perform well.
Even if it has a lot of time to think about the answers.
So it's like the AI being tested on material it hasn't been prepared for.
Exactly.
It's venturing into unfamiliar territory.
And that can lead to mistakes, even if the AI spends a lot of time searching for the right answer. The inverse scaling law is a reminder that more isn't always better, and researchers are actively trying to mitigate its effects.
Okay, so we've explored policy initialization reward design, and now the fascinating world of search. What's next on our journey to understanding O1?
Next, we'll dive into learning. This is where things get really interesting.
Okay.
The AI takes all the knowledge and experience it's gained through search and uses it to improve its decision-making process.
So it's like the AI reflecting on its experiences and refining its strategies based on what it's learned.
Yeah.
But why do we need additional learning if the AI already has a well-initialized policy from all that initial training data?
That's a great question. While policy initialization lays the groundwork, reinforcement learning lets the AI go beyond human-level performance. Think about it. Humans are pretty good at figuring things out, but we're limited by our own experiences and knowledge.
Right.
Reinforcement learning allows the AI to discover new solutions that humans might never have thought of.
Wow, that's pretty amazing. So the AI is breaking free from the constraints of human knowledge.
Exactly. And it does this by learning from its interactions with the environment, just like we humans learn from our experiences.
I'm starting to see how all these pieces fit together. But before we go any further, I have another question about this learning process.
Yeah.
What kind of data does the AI use to learn? Is it the same data it uses during search?
That's a sharp question. Not always. It depends on the specific learning method. In test time search, the AI might only use the data from the optimal solution it found, but But in train time search, the AI might use data from all the solutions it explored, including the ones that didn't work out so well.
Okay, so it's like the AI learning from both its successes and its failures. Kind of like how we humans often learn the most from our mistakes.
And that ability to learn from both positive and negative examples is one of the key strengths of reinforcement learning. Now, are you ready to explore some of the specific learning methods?
Absolutely. Let's dive in.
Let's start with policy gradient methods.
Okay.
These methods directly optimize the AI's decision-making process based on the rewards it receives.
So it's like the AI constantly tweaking its strategy to get better at achieving its goals. Always striving for that A+ ad.
Exactly. And there are several different policy gradient algorithms, each with its own strengths and weaknesses.
Okay, I'm ready for an algorithm rundown.
One of the simplest is called reinforce.
Okay.
It involves updating the AI's policy based on the rewards it gets for each action it takes.
Okay.
It's a straightforward approach, but the updates can be a bit erratic.
So it's like the AI making big, unpredictable leaps in its learning rather than taking small, steady steps.
Exactly. To address this issue, researchers have developed more sophisticated algorithms, like actor-critic methods, which involve learning two separate components, an actor that chooses actions, and a critic that evaluates those actions.
So it's like having a coach who can provide more nuanced and consistent feedback than just a simple reward or penalty.
Makes sense.
Are there any other popular policy gradient methods?
Two of the most popular and effective are proximal policy optimization, PPO, and direct policy optimization, DPO.
Okay, those are some serious acronyms. What makes PPO and DPO stand out?
PPO is known for its stability and efficiency. It limits how much the policy can change at each update, preventing the AI from making rash decisions that could throw its learning off track. DPO, on the other hand, is known for its simplicity and its ability to work without a separate value model, which can save on computation.
So PPO is like the cautious and methodical learner, while DPO is the quick and efficient learner.
That's a great way to put it. And both PPO and DPO have been used successfully in RLHF, which stands for Reinforcement Learning from Human Feedback.
Oh yeah, RLHF, we talked about that earlier. In the context of reward design, it's all about aligning the AI with human values.
Exactly. And it's worth noting that researchers are constantly refining these algorithms, coming up with new tricks to improve their performance.
It's amazing how much ingenuity goes into this field. So that's policy gradient. What about behavior cloning? How does that work?
Behavior cloning involves training the AI to mimic an expert's behavior. It's like watching a master craftsman at work and trying to imitate their technique.
So it's less about the AI figuring things out on its own. And more about learning from demonstrations.
Precisely. And in reinforcement learning, the expert might be the AI itself, but with a more advanced policy. It's like the AI learning from a future version of itself, one that has already mastered the task.
Wait, the AI learning from itself? That sounds pretty meta. How does that actually work?
It's based on the idea that the AI can discover better solutions than its current policy through search. By cloning the behavior of this more advanced version of itself, it can accelerate its learning.
So it's like the AI having a glimpse into its own potential and then striving to reach that potential. Pretty cool. What are some examples of behavior cloning in action?
One well-known example is expert iteration, where the AI uses a search algorithm like Monte Carlo Tree Search to generate expert demonstrations and then trains its policy to imitate those demonstrations.
So it's like the AI practicing and perfecting its skills by imitating its own best performances.
Exactly. This approach has been used successfully in systems like AlphaGo Zero, which achieves superhuman performance in Go. The paper also mentions STAR, self-taught reasoner. STAR. It uses a simpler approach where the AI generates multiple solutions and then selects the best one based on its own internal evaluation. It's like the AI having a quality control system that filters out low-quality outputs and focuses on the good ones.
Exactly. It's a simpler and potentially more efficient way to achieve similar results to other policy gradient methods. Okay, so we've got policy gradient and behavior cloning as our two main learning methods. What about O1? What kind of learning methods do you think it might be using? It's clearly a very capable system, so it must have some pretty sophisticated learning mechanisms.
You're absolutely right. Given O1's capabilities, it likely uses a combination of learning methods, maybe starting with behavior cloning to quickly bootstrap its learning and then transitioning to policy gradient methods to further optimize its policy.
So it's like the AI starting with imitation, and then graduating to more sophisticated learning as it gains experience.
That approach has been proven effective
Right.
in some of the most advanced large language models like LAM-A2 and LAM-A3.
Okay.
But even with these advances, scaling reinforcement learning presents several challenges.
What kind of challenges are we talking about?
One is distribution shift. If the data the AI encounters during training is different from the data it encounters in the real world, its performance can suffer.
So it's like studying for an exam with practice questions that are different from the actual exam questions.
Yeah.
Not ideal.
Exactly. And this is especially challenging in reinforcement learning because the AI is constantly interacting with the environment and generating new data.
Okay. I see how that could create a moving target for the AI. What are some other challenges researchers are facing?
Another challenge is the computational cost of reinforcement learning. Training these large AI models can require a lot of computing power and time.
That makes sense. So it's not just about the algorithms, it's also about the hardware and resources needed to train these systems. What are researchers doing to make reinforcement learning more efficient?
They're developing more efficient algorithms and leveraging transfer learning, where an AI model trained on one task can be fine-tuned for a related task. It's like the AI building upon its existing knowledge instead of starting from scratch every time.
That's a smart approach. So it seems like there's still a lot of work to be done in this area.
There is. But researchers are making significant progress, and these learning methods are pushing the boundaries of what AI can achieve. Now, before we wrap up part 1, are you ready for a quick detour into the world of open source O1 projects?
Absolutely. This is one of the things I'm most curious about. Let's go.
These open source projects are like windows into the world of O1.
Okay.
They aim to recreate its capabilities using publicly available tools and resources, giving us a glimpse of what's going on under the hood.
It's like having access to the blueprints and schematics of a super advanced AI. That's amazing.
Yeah.
What are some of the most interesting projects out there?
There are quite a few, each with its own unique approach. One project that's garnered a lot of attention is called G1. It attempts to reproduce O1-like reasoning using a powerful language model called Llama, running on a specialized hardware platform called Grok.
Okay, so they're using cutting-edge hardware and software to try and replicate O1's abilities.
Yeah.
What's their secret sauce?
One of their key insights is the power of well-crafted prompts. They use carefully designed prompts to guide the model's reasoning process. And they've even developed a feature called prompt thinking to make the AI more deliberate and reflective.
Prompt thinking. That sounds intriguing. What's that all about?
It involves having the AI explicitly think about the prompt and its implications before generating a response. It's like pausing to consider all angles of a question before jumping to an answer.
That makes a lot of sense. It's like encouraging the AI to be more thoughtful and less impulsive in its responses.
Yeah.
What are some other open source projects that are pushing the boundaries?
Another project that's making waves is Claude. It's a large language model developed with a focus on safety and helpfulness.
Safety and helpfulness. Those seem like crucial considerations.
They are.
Especially as AI systems become more powerful and prevalent.
Absolutely. And Claude incorporates several techniques to promote those qualities. For example, they use a technique called constitutional AI to train the model on a set of principles or guidelines that promote ethical and responsible behavior.
So it's like giving the AI a moral compass
to
guide its actions. That's reassuring. And like G1, it also uses prompts to steer its reasoning.
Yes. It leverages prompts to elicit specific reasoning patterns and responses from the model. And they've also incorporated techniques like self-consistency to improve the quality of its output.
Self-consistency, what's that all about?
It involves generating multiple responses to the same prompt and then selecting the most consistent or coherent one. Think of it like having the AI double-check its work to make sure it's not contradicting itself.
That's a clever approach. Okay, what about projects that are specifically trying to replicate O1?
One project that takes a very direct approach is called OpenO1. They're focused on providing a massive data set for supervised fine-tuning, SFT, that's designed to mimic the style and reasoning patterns of O1.
So instead of trying to perfectly replicate the system itself, they're providing the raw materials for others to build upon.
Exactly. It's a valuable resource for researchers who want to experiment with their own O1-like models. They can use this data set to train their models to think and respond like O1 without having to start from scratch.
Okay, that makes sense.
Yeah.
What about O1 Journey? What are they up to?
O1 Journey is a fascinating project. Laid out in 2 technical reports. The first part focuses on reinforcement learning, utilizing a powerful language model called GPT-4 to refine the training data.
So they're using GPT-4 as a kind of AI mentor to guide the learning process.
Exactly. They have GPT-4 evaluate the AI's responses,
Okay.
providing feedback and suggestions for improvement. It's like having a world-class tutor, helping the AI refine its skills.
And what's the outcome of this approach?
The models trained using this method show a remarkable ability for self-reflection, which is a hallmark of O1's reasoning abilities.
Wow, that's impressive.
Yeah.
So they're essentially training the AI to think about its own thinking, to analyze its own reasoning process, and identify areas for improvement.
Exactly. And the second part of O1 Journey takes a completely different approach, focusing on knowledge distillation.
Knowledge distillation. You're going to have to break that one down for me.
Imagine trying to capture the essence of a wise and experienced teacher in a more compact and accessible form. That's the idea behind knowledge distillation. In this case, they're trying to distill the knowledge and reasoning abilities of a smaller, more accessible version of O1, called O1 Mini, into a larger language model.
So it's like transferring the wisdom of a master into a more readily available format. And what's amazing is that the distilled model actually performs better than the original O1 Mini on some reasoning tasks.
Yes. It's a testament to the power of distillation as a technique for creating more capable AI systems.
Okay. I'm starting to see how these open source projects are not just replicating O1, but also pushing the boundaries in new and exciting directions. What other projects are out there that are taking a unique approach?
One that stands out is Open Reasoner. They take inspiration from game-playing AIs like AlphaGo, using Monte Carlo Tree Search to find optimal solutions. However, they only applied this search during testing. During training, they rely on a more traditional approach of sampling data from the AI's current policy.
Interesting. So it's like the AI is training in a more relaxed and exploratory way, and then switching gears to a more focused and strategic mode when it's time to put its skills to the test.
Exactly. And they also incorporate a sophisticated reward model to guide the learning process. It's similar to the one used in Math Shepherd, an impressive AI system for mathematical reasoning.
So it's like they're combining insights from different AI domains to create a more powerful and versatile system.
Precisely.
Okay. What about slow thinking with LLMs? That sounds like a very deliberate and philosophical approach.
It is. This project emphasizes the importance of giving the AI time to think things through, carefully avoiding hasty or impulsive decisions.
So it's like encouraging the AI to be more like a chess grandmaster, carefully considering all possible moves before making a decision.
Exactly. And they use a combination of techniques to achieve this, including supervised fine-tuning, reinforcement learning with direct policy optimization, and Monte Carlo Tree Search.
That's quite a toolkit.
Yeah.
And has this approach been successful?
Yes. They've achieved impressive results on some pretty challenging reasoning tasks.
Wow.
Showing that sometimes slow and steady really does win the race in AI.
I love that. It reminds me of the saying, measure twice, cut once. It seems like taking the time to think things through carefully can pay off even for AIs.
Absolutely. Another project that emphasizes deliberation is Marco O1. It combines data from OpenO1 with data the model generates itself using Monte Carlo Tree Search, but one of its most unique features is the focus on self-reflection. At each step, the AI critiques its own reasoning, looking for potential errors or areas for improvement.
So it's like the AI is engaging in a constant internal dialogue, questioning its own assumptions and striving for greater accuracy.
Exactly. And the self-reflective approach has been shown to make the search process more effective.
Okay, that's Marco O1. What about O1 Coder? Is that also focused on reasoning, or does it have a different specialty?
O1 Coder focuses specifically on code generation, trying to recreate O1's impressive capabilities in that domain. And they're using a fascinating combination of techniques to achieve this.
Okay, I'm curious. What kind of techniques are they using?
One is a process reward model, which encourages the AI to focus on the quality of its code at each step. Another is Monte Carlo Tree Search, which helps the AI explore different coding strategies. And they're also using both proximal policy optimization and direct policy optimization to fine-tune the model's policy.
Wow, that's a lot of firepower.
Yeah.
And is it working? Is O1 Coder actually generating good code?
Yes, it's achieved remarkable results.
Wow.
On code generation benchmarks.
That's amazing. So we've got projects focusing on general reasoning projects, tackling specific domains like coding, and projects exploring new and innovative techniques like knowledge distillation and self-reflection. It's truly incredible how these open source efforts are pushing the boundaries of AI and making these powerful technologies more accessible. It makes me wonder what's next for these systems. What will the future hold for O1 and its open source counterparts?
That's the big question, isn't it? The field of AI is constantly evolving.
Yeah.
So it's hard to predict exactly what the future holds. But we can look at some of the trends and research directions to get a glimpse of what might be coming. One area that's generating a lot of excitement is the development of more general-purpose AI systems.
So moving beyond specialized AIs that are good at specific tasks like playing chess or generating code, and towards more versatile AIs that can tackle a wider range of challenges.
Exactly, and this would open up so many possibilities. Imagine an AI that can help you with everything from writing a novel to designing a website to even composing a symphony.
Wow, that would be incredible. What are some of the challenges in developing these more general-purpose AI systems?
One of the biggest challenges is finding ways to effectively train these systems on a wider range of tasks and data.
Right. It's not as simple as just throwing more data at the problem.
Yeah.
You need to find ways to structure the training process so the AI can learn and generalize effectively.
Exactly. And another challenge is ensuring that these more general-purpose AI systems are safe and reliable. As these systems become more powerful, we need to be even more careful about how we design and deploy them.
That makes sense. It's like giving someone a powerful tool. You want to make sure they know how to use it responsibly. What are some other exciting research directions in this field?
Another area that's full of potential is incorporating multiple modalities into these systems.
Multiple modalities. You're going to have to refresh my memory on what that means.
It refers to integrating different types of data like images, audio, and video into the AI's reasoning process. Imagine an AI that can not only understand text, but also interpret images, analyze sounds, and even watch videos.
That's incredible. It's like giving the AI senses, allowing it to experience the world in a much richer way.
Exactly. And this could lead to breakthroughs in all sorts of areas. Imagine an AI that can help doctors diagnose diseases by analyzing medical images, or an AI that can help architects design buildings by understanding the acoustics of different materials.
The possibilities are endless. But I imagine there are challenges in incorporating multiple modalities, right?
There are. One of the biggest challenges is aligning or grounding different modalities, particularly with language. It's not enough to simply feed the AI a bunch of images and text. We need to teach it to understand the relationships between these modalities to see how they connect and inform each other.
So it's like teaching the AI to see the connections between words and pictures, between sounds and meanings.
Exactly. And this is a complex and challenging problem that researchers are actively working on.
Wow. It's mind-boggling to think about how much progress has been made in this field in such a short time. And it sounds like we're just scratching the surface of what's possible.
We are. The field of AI is moving at an incredible pace, and new breakthroughs are happening all the time.
Okay, so before we wrap up part 2 of our deep dive, let's take a step back and look at the bigger picture. We've explored the inner workings of these AI systems, from policy initialization and reward design to search and learning, and we've even ventured into the fascinating world of open source projects that are trying to recreate and extend these capabilities. But what does it all mean? What's the significance of this research, and what implications might it have for the future?
That's the million-dollar question. The research into systems like O1 is pushing the boundaries of what we thought was possible with AI. It's giving us a glimpse into a future where AI systems can reason, problem solve, and even create in ways that were once thought to be the exclusive domain of humans.
That's both exciting and a little daunting, isn't it?
It is, and it raises all sorts of questions about the role of AI in society, the future of work, and even the very nature of intelligence.
Okay, well, we've certainly given our listener a lot to ponder. Are you ready to move on to part 3?
Absolutely. Let's do it.
Okay, so we've covered policy initialization, reward design, search learning, and even dipped our toes into the world of open source O1 projects.
We've been on quite a journey.
We have. But I think there's one more piece of the puzzle we need to explore.
What's that?
The limitations and potential downsides of these incredibly powerful AI systems.
Ah, yes. That's a crucial aspect we can't ignore.
Exactly. So let's start with the limitations. What are some of the things that even these advanced AI systems struggle with?
Well, one of the biggest limitations is their reliance on massive amounts of data. These models need to be trained on huge data sets to perform well. And even then, they can still make mistakes. especially when they encounter data that's very different from what they were trained on.
Right. It's like trying to learn a new language by only studying a textbook.
Yeah.
You might be able to read and write, but you'll struggle to understand native speakers.
Exactly. And this issue of distribution shift, as it's called, can be a major challenge for AI systems.
It makes sense. If the AI hasn't seen enough examples of a particular type of data, it's going to have a hard time making accurate predictions or decisions.
Precisely. And this is especially problematic in areas like healthcare or finance, where the consequences of making a wrong decision can be significant.
Absolutely. So data dependence is a big limitation. Are there any others?
Another limitation is their lack of common sense or real-world understanding. While these AI systems can process information and solve problems in ways that often surpass human capability, they still struggle with tasks that require common sense or an understanding of the nuances of human behavior and social interactions.
So they can beat a grandmaster at chess, but they might struggle to understand a joke or a sarcastic comment.
Exactly. They lack the kind of intuitive understanding of the world that humans develop through years of experience and social interaction.
That makes sense. Okay, so data dependence and a lack of common sense are two big limitations. What about potential downsides or risks? What should we be cautious about as these AI systems become more powerful and prevalent?
One of the biggest concerns is the potential for bias. If these AI systems are trained on biased data, they can perpetuate and even amplify those biases in their outputs.
Right. It's like the old saying, garbage in, garbage out. If you feed the AI biased information, it's going to produce biased results.
Exactly. And this can have serious consequences, especially in areas like hiring criminal justice or loan applications, where biased decisions can have a real impact on people's lives.
Absolutely. So bias is a major concern. What about the potential for job displacement? As these AI systems become more capable, are they going to start taking over jobs that are currently done by humans?
That's a question that's been debated for years, and there's no easy answer. It's certainly true that some jobs, particularly those involving repetitive tasks or data analysis, are likely to be automated as AI technology advances.
Right. It makes sense that AI would excel at those kinds of tasks.
Yeah.
But what about jobs that require creativity, critical thinking, or emotional intelligence? Are those safe from automation?
That's a good question. And while those skills are harder to automate, it's not impossible. AI is already being used in fields like art, music, and writing. And as these systems become more sophisticated, they may well be able to perform tasks that we currently think of as requiring uniquely human abilities.
So there's not just blue-collar jobs that are at risk. White-collar jobs could be impacted as well.
It's certainly possible. And I think it's important to start thinking now about how we can adapt to these changes and prepare for a future where AI plays a significant role in the workplace.
I agree. It seems like the key is to focus on developing skills that are difficult for AI to replicate. Things like creativity, critical thinking, problem solving, and interpersonal skills.
Absolutely. And I think it's also important to remember that AI can be a powerful tool for good. It can help us solve some of the world's most pressing problems, from climate change to disease.
So it's not all doom and gloom. AI has the potential to make our lives better in many ways.
Exactly. It's all about how we choose to develop and use this technology. And that's why it's so important to have these conversations and to think critically about the implications of AI for our future.
Well said. I think that's a great takeaway for our listeners. We need to approach AI with both excitement and caution. We need to embrace its potential while also being mindful of its limitations and risks.
Exactly. And we need to work together to ensure that AI is used in a way that benefits all of humanity.
Absolutely. Well, I think we've covered just about everything. Any final thoughts before we wrap up this deep dive?
Just one. This field is evolving rapidly, so what we've discussed today is just a snapshot in time. What's exciting is that we're all part of this unfolding story. We're witnessing the birth of a new era of intelligence, and it's up to us to shape how it unfolds.
I love that. It's both empowering and a little bit scary, but that's what makes it so fascinating. To our listener, thank you for joining us on this incredible journey into the world of AI. We hope you've learned something new and that you're as excited about the future of AI as we are. Until next time, keep exploring, keep learning, and keep asking questions. The future is waiting to be discovered.